This video will demonstrate how to perform the insulation resistance tests. This test is performed on the whole installation, the consumer mains and the submains to save time, but a low result means the circuits must be tested individually. The device and setting. To test insulation resistance, you need an insulation resistance tester. When selecting 500 volts DC, you are also selecting 200 mega ohms device setup. Prior to testing, check the battery is okay, the testing leads, and place them in the correct terminals of the meter. Select the 500 volt DC. You do not have to zero the meter for an insulation resistance test, but you should check that the meter is functioning correctly by measuring a known resistance value of 1 mega ohm. Use a multimeter on voltage DC across the 1 mega ohm resistor and confirm the voltage tolerance is either plus 20% or minus 10% of 500 volts. One mega ohm. (508 volts). Circuit setup. Ensure supply is isolated to the electrical installation. Disconnect the MEN links at every switchboard. Disconnect all portable appliances. Turn on every switch to every appliance, GPO and lighting points, but avoid damage to electronic devices. The fluorescent light has got an electronic ballast, but I will turn it on to test between active and earth and neutral and earth. I will remember to turn it off when I'm testing between active and neutral. I have a two-way lighting circuit. I'm going to press one switch on. I must conduct the test twice. To test the insulation resistance test of the whole installation, turn on every main switch, every circuit breaker, and every RCD in the switchboard. Including the distribution board. Use the bridging leads to short together the active phases to the neutral. Place one probe to the earth bar, place the other probe to the shorted actives and neutral. The test result must be greater than 1 mega ohm. Greater than 1 mega ohm. Change the switch position on the two-way switching. The result is still 1 mega ohm. Press in the contactor to the fire pump. The result is still greater than 1 mega ohm. To test the insulation resistance of the consumer's main, turn all main switches off. General light and power, main switch, off. Hot water service, off. Fire pump, main switch, off. Remove the bridging leads from the active phases and neutral. Test between each active to earth, between each active to neutral, and between actives and finally between the neutral to earth. The test result must be greater than 1 megaohm. Red phase to earth, greater than 200 megaohms. White phase to earth, greater than 200 megaohms. Blue phase to earth, greater than 200 megaohms. When testing active to neutral, it's important to realise there might be services that have got elements in them. So I've disconnected the active of the stove and the active of the hot water system. Red phase to neutral, greater than 200 megaohms. White phase to neutral, greater than 200 megaohms. Blue phase to neutral, greater than 200 megaohms. Test between actives. Red phase to blue phase, greater than 200 megaohms. White phase to blue phase, greater than 200 megaohms. Red phase to white phase, greater than 200 megaohms. And finally, test between neutral and earth. Neutral to earth, greater than 200 megaohms. Insulation resistance test of the submains. Disconnect the submains active and neutral at the switchboard and bridge together with a bridging lead. Place one probe on the distribution board earth bar and one probe on the active and neutral join. Greater than 200 megaohms. A result of less than 1 megaohm on the whole installation means that you must test each circuit individually to locate the circuit with the fault. Turn every main switch, circuit breaker and RCD off. Test each active to earth and each neutral to earth separately. Lighting circuit active to earth, infinity. Power circuit 1, infinity. 3-phase outlet, red phase, infinity. White phase, infinity. Blue phase, infinity. I'll continue this on throughout the circuit. Stove, infinity. Lighting circuit 2, infinity. Power circuit 2, infinity. Hot water service, infinity. Fire pump with the contactor pressed in, infinity. White phase, infinity. Blue phase, infinity. I then do the same on the distribution board. Lighting circuit, active to earth, infinity. Power circuit, active to earth, infinity. If I have a short on the neutral to earth, then I must disconnect each neutral separately and test it to earth. And continue along until I've tested all the neutrals. Infinity. Any results less than 1 megaohm identifies a faulty circuit. After repairing the fault, you should retest the whole installation to confirm no short circuits still exist. You are now ready to conduct polarity testing of the electrical installation.